Hi, calculus students. These notes are on infinite limits. So the basic idea here is that we're looking at when there are asymptotes in the graph and how do we determine what the limit is. Okay, so the idea is given the limit as x goes to some x value we're calling a of f of x, our question that we're wondering is what happens when if I plug in and get f of a, I get a number over 0. So what happens when f of a is undefined, but it's not indeterminate? It's not, and remember, indeterminate is 0 over 0. And the idea is that's so we're thinking about when you get a number over 0. Okay? And the idea of our exploration in class was that we saw that there's an asymptote, right? So this, if whenever we get a number over 0, we see there's an asymptote. Okay, so now when there's an asymptote, remember there's kind of like 3 possibilities of what that asymptote can look like graphically. The first possibility would be where as you approach the asymptote, say at this some a value or some x value a, if we approach that asymptote from both sides, they are both going up towards infinity. And the idea then, if I asked you what's the limit here, as x goes to a of f of x, we would call this the limit as infinity. I could also say does not exist, but one option is infinity. And for our purposes, when we're doing these infinite limits, we're going to call it infinity if they're both sides are pointing up. The second situation would be both sides pointing down. And then I would say the limit as x goes to a of f of x would be negative infinity. And again, it's D and E too, but because they're both going towards the same infinite, like sign of infinity, we can also call it negative infinity. And then the last situation, which I guess there's like 2 subsets, but is that the 2 different sides are going, as you approach the asymptote from both sides, one side is facing up, one side is going down. And again, like I said, there's kind of like 2 subcases of this because it could go the opposite way. So here, now this is the situation where I can't say positive or negative infinity. I can only say does not exist because the sign of this is negative infinity, this is positive infinity, they do not match, does not exist. Okay. So these are kind of like visually, these are the 3 kind of different situations that could happen when we plug in and we get a number over 0. Okay, so the idea of this process that I'm about to show you is that we'd like to know, well, are both sides going up? Are both sides going down? Or is one side going up and the other side going down? And we have a strategy of how we can figure this out, which essentially involves plugging in an x value that's on either side of a. So I plug in a point a little bit to the left, plug in a point a little bit to the right, and then depending on if we get something positive or negative, that's going to determine if the limit goes to positive infinity or negative infinity. So let's look at an example. My first example is going to be the limit as x goes to negative 2 of negative 3 over x plus 2. So my first step here is exactly the same as when I'm doing other limits algebraically. I'm going to start by plugging in the x value and seeing what I get. And that kind of will determine That's always your first step, and then we'll see what happens, and that kind of determines where you go from there. So what happens if we plug in an x value here? We're going to plug in -2, so we get -3 over -2 plus 2, which is -3 over 0. So we get undefined, but not indeterminate. So the next thing we're going to do is we're going to plug in an x value on either side of -2. So what are good x values to plug in? We want to do something close enough to that x value, so we're going to just basically move a tenth of a point over to the left and a tenth of a point over to the right. So what does that look like? So left of -2 means basically like subtracting 0.1 from -2. That becomes -2.1. That's a point just to the left of -2. So what happens when I plug in -2.1 in for the x here? Well, I get -3 over -2.1 plus 2. Now, the important thing here that I want to stress is that I don't actually care what the answer is. I just care if my answer is positive or negative. Because if I get something positive, that's telling me that as I approach it from the left, the asymptote's going up. If I get something negative, that's telling me my asymptote's going down, because as long as I'm plugging something in close enough to the asymptote, it should definitely give me something either positive or negative that correlates to positive infinity or negative infinity. So here, my answer, I'm going to switch, when I write my answer, I'm just going to put either a plus or a minus sign in the numerator and the denominator to kind of keep track of my signs. So my numerator is -3, that's definitely negative. And my denominator is -2.1 plus 2. Well, I know I have like a larger negative number than a positive number, so I know that that will be negative. So if I have a negative divided by a negative, I know that will equal something positive. So I'm circling this plus sign because that's giving me my left-handed limit. That's telling me that the limit, as I approach -2 from the negative side, because I plugged in a place to the left, of this function, I'm going to call f of x, is equal to positive infinity because I got a plus sign. Now we're going to repeat the process on the right. So what's a number to the right of -2? -1.9. So I just went point like a tenth over the other way. Now what happens when I plug in? I get -3 over -1.9 plus 2. My top is still negative. The bottom part is -1.9 plus 2, I know that's going to be a positive thing. And now I have negative divided by positive, which will be negative. So my conclusion would be that the limit as x approaches -2 from the positive side is equal to negative infinity. Okay, so again, I'm plugging in a point on either side. I'm getting the sign of that value, and that's allowing me to conclude the sign of the infinity of each of the left and the right-handed limits. Okay, now my last thing I need to do is draw my conclusion based on the left and right-handed limits. So are these two limits the same? No, one's positive, one's negative. So I end up with my third solution, my third possibility. Therefore, I'm going to say that the limit as x goes to -2 does not exist. And that would be my final answer. So I'm kind of rewriting out the original problem. And now I know that this does not exist based on all of the work I just did. So it's a little bit of a tedious process, but it always will work whenever we have a number divided by 0. So let's look at another example. So my next example is the limit as x goes to -1 of x over x squared minus 3x minus 4. So my first step is to plug in -1. When I plug in -1, I get -1 over -1 squared minus 3 times -1 minus 4. Well, that's positive 4 minus 4, so I end up with -1 over 0. So we get undefined but not indeterminate. Now we're going to be plugging in an x value on either side of -1. And one quick thing I'm going to say here is that because we care about not the value of our answer, the numerical value, but just the sign of our answer, it's going to be easier to figure that out if you factor first, okay? So it's always going to be easier if you factor first when you can. So what I notice in this problem is that I can factor my denominator, and I'm going to do that from the beginning just because it's going to make plugging in these decimals easier. So then I would have x minus 4 and x plus 1. So I'm thinking about plugging in to the factored form. And let's see, something to the left of -1 is going to be -1.1. So what happens when I plug in -1.1? I get -1.1 over -1.1 minus 4 and -1.1 plus 1. Okay. Now again, don't be scared off by this. I don't care what the numbers are. I just care about the signs. So on top, it's negative. On the bottom, the first parenthesis, something negative minus 4, it's going to still be negative. And my second parenthesis is something negative plus 1, and this is bigger than that, so that's negative as well. So now I can see on the top I have something negative. On the bottom I have negative times negative, which would be positive. And then my overall answer will be negative. Okay, that's a lot easier to figure out than if I were to plug in -1.1 up here into this quadratic and have to think about if it's positive or negative. So then what is this telling me? It's telling me that the limit as x goes to -1 from the negative side, and I'm going to call this f of x so I don't have to rewrite it, is equal to -infinity. So now I'm going to do the right side. And that would be -0.9. So on top, I get something negative. On the bottom, this is -0.9 minus 4. That's still negative. But the second parenthesis, this will now be positive because -0.9 is not large, doesn't have a larger absolute value than 1. So altogether, I have negative over negative now, because negative times positive is negative, which means I get something positive. So what does this tell me? This tells me that the limit as x goes to -1 from the positive side will equal positive infinity. Okay, and then my last step is to compare these two, right? So we compare, do they match? No. So what does that tell us? That tells me that my overall limit doesn't exist because I don't have the same sign of my infinities. Okay, so we've now done that whole example problem. We're going to be practicing this next class, but I want to give you one problem to try on your own. So it's the limit as x goes to 3 of x plus 2 over x squared minus 9. So think about like using the steps we just listed in these examples to help you to get to an answer for this problem.